Hello dear students, how do you do? Very good morning to you all. All of you have had your breakfast? Yes, I too had and came for the class. Okay. In the last class, we have completed up to all water surface profiles. They are mild slope. Yeah, we completed up to all the bed slopes, various slopes, mild slope, steep slope, critical slope, horizontal bed slope or horizontal slope, and adverse slope. So we have understood each and every content. Just as a summary, in order to summarize, mild slope exists in all the three zones, zone 1, zone 2, zone 3, and steep slope also exists in all the three zones, zone 1, zone 2, zone 3. What do you mean by zone? Zone 1 is nothing but above the NDL or CDL. In between NDL and CDL, zone 2. In between NDL or CDL and the bed slope, that is bed of the channel, we call it as zone 3. In order to say mild slope, condition is Y, that is the depth of surface profile from the bed of the channel. Y is greater than Yn is greater than Yc, that is M1. M2, if Yn is greater than Y is greater than Yc. M3, Yn is greater than Yc greater than Y. In detail along with the sketches, we have understood very clearly when mild slope exists and what are the applications. In the similar way, steep slope exists 3, critical slope exists only in 2 zones, that is 1 and 3 zone. Horizontal slope and adverse slopes respectively exist on zone 2 and zone 3 because Yn becomes infinity in both these cases. Okay? Let us continue. Control section. A control section is defined as a section in which a fixed relationship exists between the discharge and the depth of flow. Weir, spillways, sluice gates are some of the typical examples of structures which give rise to control sections. The critical depth is also a control point, of course. However, control point is effective in a flow profile which changes from subcritical to supercritical flow. So, always the changes from subcritical to supercritical flow, wherein control point is effective in such profiles. Any profile may be. In case of transition from supercritical flow to subcritical flow, in case of transition, a hydraulic jump is usually formed by passing the critical depth as a control point. Any GVF profile will have at least one control section. Remember, any GVF profile, whether mild, steep, critical, horizontal or adverse, at least one control section exists. In the synthesis of GVF profiles, which is shown in figure, control section, you can understand by zooming if you want. Here, for example, it is shown bed slope, CDL, NDL, mild slope, M1, mild slope, M1. Serially connected channel elements, the control sections provide a key to the identification of proper profile shapes. It may be noted that subcritical flows have controls in the downstream end while supercritical flows are governed by control sections existing at the upstream end of the channel section. So always it controls, and also engineer will come to know up to what length these profile occur. In worst situation like heavy floods, what happens? It may allow all the cultivation land or adjoining lands in submergence. So in that case, before we construct such dams, what we are what we are required to understand, if I construct during flood season or monsoon season, when flood occurs, what would be the ill effect on the public in the society, whether their land properties or any other properties may submerge. For that, up to what length these surface profiles occur should be known. Accordingly, it can be controlled, right? So for that purpose, this control section is very, very essential. In figure M1 profile, the control section is just upstream of the spillway and sluice gate respectively. Examples are shown in the form of photographs also. In figure of M3 and S3 profiles, the control point is at the vena contracta of the sluice gate flow. You see the difference between these two. In case of M1 profile, the control section is just upstream of the spillway and sluice gate respectively, on upstream side here control section. Whereas in case of M3 profile, it is on the vena contracta of sluice gate flow. This is sluice gate. Okay. In subcritical flow, reservoir takes off. Even though the discharge is governed by the reservoir elevation, the channel entry section is not strictly a control section. The critical depth at the free overflow of the channel end acts as the downstream control here on the downstream. This is upstream, this is upstream, this is downstream. Okay. For a supercritical canal intake, the reservoir water surface falls to the critical depth at the head of the canal, and then onwards the water surface follows the S2 curve here. This is control section. So it follows after the control section as S2 profile in case of reservoir water surface falls. The critical depth occurring at the upstream end of the canal is the control for this flow. That means whenever such profiles occurs or exist, in case of a reservoir, when supercritical flow canal intake, it falls to the critical depth. And one more important point is, critical depth occurring at the upstream end of the canal is the control for this particular flow. Several control sections are shown here. In many engineering problems, whatever I have already pointed out, it is necessary to know the length up to which the effect of particular profile exists. What would be the ill effect when it occurs or exists, which may changes the condition of the flow. For example, if hydraulic structure is to be constructed on a channel like, say, dam, I have already given the example and narrated, then there may be a development of M1 profile on the upstream of the dam. In such cases, answer of such questions are required, like up to how much length depth of flow will change in the upstream direction and by which depth. What would be the depth? What would be the depth? That is Y or D. What would be the length of the profile total? What will be the flood situation after dam in the river? How much land will be submerged or flooded in water? I have already given this example. Before I come to this paragraph to read the sentences printed, I have already narrated just in the previous PPT itself at the beginning. Similarly, there may be development of M3 or H3 on the downstream side of the dam. Then the computation would help to identify at what profile jump will take place. What should be the length of guide wall or training walls on the downstream side of the jump. So we have to evaluate these so that we can construct such guide walls or training walls so as to control the flow and to prevent any submergence or flooding of lands. What should be required length to apron for the jump? So how much long we have to provide the apron for this jump will occur due to occurrence of these profiles on the downstream side when M3 or H3 profiles are occurring. Is it clear concept? Yes. If you listen with interest, definitely you can understand. Since you are students and studying for the first time, may not be 100% you have understood now. At least you feel that, yes, something we have understood. So when you read and listen to this video, what shows many number of times, 3 times, 4 times, definitely it will be understood. Don't forget to refer the figures. Always sentence पढ़ने का या paragraph पढ़ने का figure कडे बघायचा. Figure is important. That will also print in your brain. So whenever you recall it, it will come out. When you write the figure properly with such profiles, upstream side, downstream side, showing control section, showing the profile in a proper way in which zone it is occurring, depending upon a particular structure is constructed, whether it is a dam, whether it is a spillway, whether it is a sluice gate, or mild slope is followed by the steep slope, etc., then there will not be any confusion to understand. Okay? Further, almost all major hydraulic engineering activities in free surface flow required computation of GVF profiles, like for the computation of the length of the profile. The procedure of GVF computation involves solution of the GVF equation by integrating it for computing the length of flow. So always the computation has to be done so as to understand what should be the total length of the profile which is occurring. Okay? And with respect to which type of profile which is occurring, whether it is occurring in zone 1, zone 2, zone 3, etc., that directs us or it makes us to understand whether CDL below the NDL or NDL is below the CDL. However, both will be above the bed of the channel slope. That you remember. It cannot come below the bed of slope because it becomes subsurface. How it could be possible? Is it not? Is it not a joke? Our students are not so fools. They are very good. Methods for GVF computations. The various available procedures for computing GVF profiles can be classified as numerical method, in which we are having simple numerical methods and advanced numerical methods. Also, in simple numerical methods, we have direct step method and standard step method. Apart from these advanced numerical methods, graphical method, direct integration method is also included. But as per your syllabus, if you refer 15 to 20 question paper previous years, in any course maybe, whether 1990 course, whether 1995 course, or 97 course, or 2002 course, 2007 course, or 2012 course, or recently yours 2015 course, irrespective of the course, and if you refer any question papers, the numerical problem is being only based on direct step method. It is the only included for numerical problems. Remember, in textbooks you will find the numerical problem solved by different methods, but all are not included because it is very lengthy calculations but they are simple but very lengthy and voluminous. That's why all the things cannot be included in one particular semester. However, all the methods, what they are, how they may be used to compute, briefly for 2 to 3 marks, theory questions may be asked, but not numerical problems on these. Okay? Is it clear now? Next. Methods. Since, as I pointed out, the graphical method, numerical methods, etc., are just to understand. These are also the methods from where we can compute GVF. But however, no numerical problem. Hence, first we shall deal with all these in quick time, and then we will go to the direct step method, detailed procedure, how GVF computations can be done so as to know the total length of a particular profile in a particular zone depending upon the structure constructed across the river and how far it will affect, up to what length it affects the land, we will discuss in detail after we discussed the one which should be known, but at length it is not included in the syllabus. Okay? Shall we continue afterwards? Okay. Bye. Have a good day. Please be in touch with the studies. Refer the figures. Okay. Refer the figures. Very correctly refer the figures and study so that you will get everything.